Hello, a short video this week where I'd like to present some updates to the olcConsoleGameEngine console game engine. Firstly, I'd like to introduce the addition of a cross-platform console game engine, which should work for Windows 7, Windows 8, Windows 10, Linux and Mac. Secondly, I'd like to introduce some sound features that I've added to the console game engine, which we'll be exploiting in later videos. And thirdly, I'd like to introduce the olcConsoleGameEngine Battle Royale, a fun community game that we've been working on the Discord server, and I'd love you all to take part. So let's get started by talking about the now several versions of the console game engine. Of course, here we have the vanilla console game engine, the best one in my opinion. I've also uploaded to the GitHub the object-oriented programming versions of the console game engine. These are the ones that we used in the RPG, and they're also used in the Battle Royale program I'll talk about at the end of this video. But in addition, we have some more flavours. If you've been running Windows 7 and some versions of Windows 8, when you've loaded the console, it's been distorted, the aspect ratio hasn't been quite right, and others have reported being hit with glitches and general slow performance. If you've had any of these problems, this one is worth a try. This is the console game engine wrapped in an OpenGL wrapper, so it actually uses OpenGL to render an emulated console. And alongside that, I've also got object-oriented programming versions of the same engine. And at the bottom of the list here, we've got the console game engine using an SDL backend. And this version should be compatible with most flavours of Linux and Mac, although I will emphasise it's still undergoing quite a bit of debugging. However, fundamentally it does work, and I'd like to demonstrate just how simple it is to choose a console game engine and use it. So I've loaded up the code for the pseudo 3D planes, also known as Mode 7, quite a popular video, which rendered a Mario Kart track, and this is going to use the vanilla olcConsoleGameEngine console game engine, so I'll click play. And there we go, as we know and love it. We've seen this before, I've not modified the code in any way. So I'll close that down. Now let's say I want to use the GL interface. All I've done is change the name of the header file. Nothing else in the code. We can click run now. And this has launched a pretty much exact simulation, except it's now using OpenGL rendering to draw the frames. So this should overcome any artifacts or glitches that you might have been having with your Windows consoles. And on Windows, we can also use the SDL version. So I'll just change that to SDL and click play. And there we go. The colours look a little bit different, but on the whole, it works exactly the same. And you'll notice I've not had to change the code at all. Everything should remain compatible. Let's just have a quick look inside the console game engine OpenGL version. I'd like to give really big thanks to CrossX from the Discord server, who has pretty much single-handedly put this together. And we'll have a quick look at the code. And what we can see, once we get past all of the comments at the start, is it does a few strange things. It has a lot of data in this header file. And this is actually font information, because it works by, instead of drawing fonts like the command prompt does, it draws sprites of characters and mixes them together in a compelling way to emulate the console. Now, most of the code will look very familiar to console game engine users. I know it's whizzing past pretty quickly here, but that's the point. It's pretty much exactly the same, except for the rendering routines, which are hidden away in the game loop. And to keep things nice and simple, as usual, it's a single file solution, so it is quite a large file now. The SDL version does have some limitations. Firstly, it doesn't support mouse input just yet. I'm working on that. What I would like to thank is Jack OJC from the Discord server, also known as Jack Clark on YouTube. I incorrectly called him Jack OLC in the 10k subscriber special, so I'm sorry about that, Jack. And this version is interesting because it's all full of things like this to make it cross-platform. So if we're on a Win32 based platform, we'll execute this instruction, but if we're on a different platform, we'll execute that instruction. To keep the rendering performance really high for SDL, the console game engine will only render the characters that change between successive frames, so this minimises the draw calls. However, in some applications, if the whole screen is changing quite rapidly, you may notice some performance drops. One final thing to mention is the SDL version requires a file called olcfont_consolus.bmp. This is an image that contains all of the glyph information that will be drawn to the screen. But in every other way, it will just emulate the console game engine as you know it. So you can follow along with all of my previous and future videos. And that's really the point of my channel. It's not really to demonstrate what the console game engine can do, it's about the code that we use to implement interesting algorithms. I just happen to use the console game engine as a rendering platform. And just to demonstrate that it is cross-platform, the best I can do is run Debian in a virtual machine. So here I'm compiling the Asteroids video code. So this is taken straight from the GitHub, and all I've done is told it to use the SDL header file. And if we run the application, we can see it's Asteroids, functioning just as it did on the Windows version. And I'm still no good at it. So I really would like to give a sincere thank you to CrossX for the OpenGL version, Jack OJC or Jack Clark for the SDL version, and quite a few testers, Mr. Bad News, Slavka, Neon, and several others on the Discord server. Thank you very much, guys, for helping this come together. If you do have problems compiling on Linux, please reach out on the Discord server. There'll be people there that can help you. But on to the next update. You may have seen this very subtle comment here, enable sound. And that's because I've enabled sound to the console game engine. And you enable it by calling the enable sound function in the constructor just after where you've named the application. And it works like this. You will store an integer which will represent an ID of an audio sample. And you can load the sample. It only loads WAVs at the moment, typically 16-bit WAVs at 44.1 kHz. Presuming the sample is loaded OK, to play it is simply a case of calling the play sample routine and passing the identifier to it. Let's take a look. So we're moving around, pressing the spacebar. And what we can see is we played multiple sounds on top of each other. There is in fact an internal mixing desk behind the scenes in the console game engine. And that's almost it for sound. The library will carry on growing as I develop more things into it, because I'm interested in revisiting sound. We've not really done any sound stuff since the synthesizer. But I will mention two additional functions. We're used to having onUserCreate and onUserUpdate. We've now also got onUserSoundSample. And this is quite an interesting one. The internal mixing desk will call this function if it exists in your code, and you can return generated sounds directly. So if I run it now, we can hear a rather annoying and very loud sound wave in the background. And that, of course, is because all I'm doing is generating a sine wave. So this should allow us to mix sound and graphics in quite a fluid way. There's a third override, onUserSoundFilter, and this is applied to the mixing desk output. So if we wanted to do post-processing effects or simply change the volume, we can do that too. So here I'm going to take the sample that's about to be delivered to the speakers, and I'm going to modulate its amplitude with another sine wave. And what we should hear is the sine wave going up and down in amplitude. And we do. In fact, it applies to all sounds coming out of the mixing desk. I like these two functions. They'll allow me to build quite a visual synthesizer application. Now the SDL version doesn't support sound yet, but the GL version does. So if I play it, we can see exactly the same behaviour. And finally in this video, I'd like to introduce Battle Royale one lone coder style. Of course this isn't going to be 100 people in a big multiplayer environment in real time trying to kill each other. When coders battle, they don't use guns, they use code. And so I've developed two things which form olc Battle Royale. The first is a simulation engine, which defines an arena filled with robots. The robots can move around and sense their environment and fire bullets at each other. And a really cool feature of this is it doesn't rely on the console at all. It is a completely encapsulated simulation. The robots run a Lua script. Now, not all of you will be familiar with Lua, but it's very simple and I think quite a powerful scripting language. And so this is an example of Javid bots. So this is going to be the AI for the bots labelled JavidX9. The first thing your bot needs to do is identify itself. And then there's only one more function, which is this update function, which is the equivalent of a main loop. And for this AI, this bot is very simple. The first thing it'll do is check its environment for obstacles, such as walls. And if there's a wall in front of it, it's going to turn right, move backwards, and turn right again. otherwise the bot's going to just move forwards. I then check where are the enemies on my map. Now not all of them will be visible, some of them can be cloaked, some of them might be shielded. If I've got an enemy right in front of me, I'm going to activate my shields. The battle simulation allows robots to be deployed in teams, so the robots can work together, and they can even communicate with each other. In this case, I want to find a robot on the map that's not a member of my team. And once I've found one, I want to turn to face the enemy, and I'm going to fire a bullet. If there are no enemies left on the playing field, maybe there's only my allies left, then I'm just going to sit in a tight loop and turn left. So it's not a very sophisticated AI script, but it demonstrates some of the basics. So let's take a look at it in action. Of course, I'm using the console game engine to display things, but because the battle simulation is completely encapsulated, you could use anything to display it, and I'm hoping the community will go ahead and start generating full 3D implementations, where we can see 3D models of the robots blowing each other up with explosions and all sorts of exciting things. So I'm going to start the simulation by pressing the spacebar.
Let the battle begin.
The robots are listed down the right hand side of the screen. In this case, the Javid bots are the cyan and green bots. And you can see they're successfully hunting down Nullbot. This is a bot that doesn't fight back. Each bot has health and an energy bar.
Player 1 eliminated.
There we go. Team Javid wins again. Yay! Can always win when the enemy doesn't fight back. And we can see the bots have now gone into the sort of resting state. They're just sitting there turning left. Now the engine can support lots of bots at the same time, but in this case I've limited it to 8 because that's all I can fit on the screen. If there's a problem with your bot, say a big ugly syntax error like this, the simulation engine will inform you. Now it also includes a debug mode, so if there is a runtime error, it will give you a similar error message. However, for actual tournament battles, I'm going to disable that, and instead the robot just malfunctions in real time in the game. It doesn't crash the game, but your robot will be represented as malfunctioning. You can also change the parameters of the tournament. So here are the physical parameters that are applied to all robots, and here are the teams. Let's add some more robots.
Let the battle begin.
So now we've got all 8 robots duking it out in real time. I think this will be lots of fun, and we'll have a tournament and championship and different gameplay modes. You just need to get stuck
Player 5 eliminated.
with creating the scripts. So that's all from me.
Player 6 eliminated.
Keeps interrupting me. So that's all for this week. If you do want to have a go at the Battle Royale, please do get involved on the Discord server, and you can download the source on the new GitHub community. The links will be in the description. I will be doing a video specific to the OLC Battle Royale, talking about how we implement Lua in C and how we handle multi-threaded applications. If you've got any problems with the new console game engine, please feel free to shout out, and I'm sure in one way or another I'll get some help to you. And I'll be doing a regular coding video for next time. Take care.